Let's consider this diagram. In the diagram below, ABC are 3 points on the same horizontal plane. ABC, this is the horizontal plane. This is the plane that is put horizontally into the floor, if I may say. Now, D is vertically above B. D is vertically above B, which means it makes 90 degrees right in the point of intersection. Then E is vertically above C. So we are having that E, which is right vertical above C, which means here there is 90 degrees. Now, the angle of elevation of E from D is theta, which means this is the angle made by D and E into this horizontal line. Now, which is theta in this case. Then therefore F is a point on EC. This is the F, is a point on EC, such that DF is parallel to BC, which means this one is now parallel to that one. All right, so that means if we know that this is a vertical is a vertical line and this is also a vertical line, you can see that we are having a parallelogram like thing, which is seemingly to be a rectangle. Now, what are we having? We are to prove that DE, where is DE? DE, this one, is equal to B sine A divided by sine A plus beta, then cos theta. So how do we go about doing this one? You can see that our BA and stuff like that are right there in this horizontal plane that is put there. So which means most of the information is just found there. So what do we need now? We really need to first find UDF, and UDF is equal to BC. So we really have to find BC to find DF. Now, how do we find BC? Using this triangle, which is the horizontal plane, we're having some information there, which is this angle opposite to this side and this angle opposite to this other side. So which means we are going to find something out here, because we indeed have this angle, and that side. Now, what do we do? We have to use sine, what do you call? Because we really have to find out this angle. What is this angle? Angle ABC is gonna be equal to 180 minus alpha plus beta. So this is what we have. This angle is equal to that one, which is, if I can put it, 180 minus alpha plus beta, which means this is just the third angle. Now, what are we having? Sine rule can help us here. Sine rule says if you are looking for BC over sine the angle that is facing BC, which is alpha, is equal to AC. AC is just B, then divided by sine the angle facing this side, which is the one we were looking for, which is what? 180 minus what? Minus A alpha plus beta. So this is what we have. So our BC now, and this one can be simplified further because you can reduce this angle. Now we're having BC, which is equal to, then this is going to multiply that numerator B there. So we have B sine alpha, this divided by, this can be reduced to say, okay, 180 minus is on the second quadrant where sine is positive. So we're just going to be having sine alpha plus beta, just like that. So we're having BC, and BC is still equal to DF. By finding this BC, we have found df. Now, on that note, we really have to, because we are having this df now, which is equal to that. Now, we have what? We have our angle theta there. We're having our angle theta. That makes us to use cos there, because we are looking for the hypotenuse having the adjacent side. So if we can just say cos theta is equal to df over what? Over de, right? So that makes us finding de being equal to df divided by cos cos theta. So in the place of df, we can put this kind of thing, because we really found df, which is equal to bc, which is equal to that thing there. Then de is going to be equal to, df is what? Df is b sine alpha divided by sine alpha plus beta, then divided by cos this. So which is going to be 1 times cos that. So indeed, in simple, we have that all divided by sine alpha plus beta, then times cos alpha. So we have solved that really de is equal to this kind of thing. So the idea is to remember the sine rule, cosine rule, and area rule if possible, and to solve these kind of things. Normally the information is used to be far away from where you're supposed to be, so you just have to drag it to where you want to use the information, so that you don't get stuck in the middle. So otherwise, see you in the next video.